This is the second part of section 5.2. Up until now, whenever we've seen an example, we have seen that we have a table where our x value is always increased by 1. That allowed us to figure out the b value, just using the pattern in the table. But what if we don't have a set of x values that go up by 1 real nicely like we've had so far? In actual fact, given any 2 points, not necessarily with consecutive x values, it's possible to find an exponential function that goes through both points. Okay? So, given 2 points, how do we find that? Here's a couple of strategies. The somewhat simpler case is the case where one of the given points is the y-intercept. In that case, of course, we already know the a value because the a value is that y value from the y-intercept. We'll then just plug in the second point, and that's going to allow us to solve for b. And we'll find the final answer with function notation. What if we're given 2 points, but one of them is not the y-intercept? In that case, I don't have anything that I know right away in terms of finding a and b. So I'm going to substitute both points into my equation. And then this is a really key step here. We'll divide the equations by one another. And what that's going to do for us is divide out the a values, allowing us to solve for b. And then we can go back to one of the first equations and solve for a. Ultimately, though, keep in mind, anytime you're solving or finding an exponential function, you got to find a and b. Let's look at some examples. In example 5, we'd like to find the equation of an exponential function that contains 0, 2, and 4, 162. This time I do have the y-intercept, so right away I know that a is going to be 2. So in terms of my exponential function, y equals ab to the x, I can write right away that y equals 2b to the x. I'm then going to take my second point, and I'm going to plug it into that equation. So y is 162 equals 2 times b to the x is 4. Now I have an equation with just one unknown, b, and I should be able to solve for that. I'll start by dividing by the 2. So I have 81 equals b to the 4th power. And then to figure out b, of course I need to get rid of that 4th power. The way I'm going to do that is actually with a fractional exponent, something we learned about in the last section, right? If I raise b to the 4th to the reciprocal power, the 1/4 power, notice that when you multiply those exponents, it's just going to be 1. So I have b to the 1st, or just b. Now, of course, if I do something on one side of an equation, I have to do it to the other side as well. So I'm going to raise 81 to the 1/4 power also. You can do this on Desmos. Just to avoid switching screens, I'm going to use my calculator. Whoops. 81 to the 1/4 power is 3. And you may have already known that. You might have thought right here, hey, I know 3 to the 4th is 81, and that's great. But of course, they're not all going to come out evenly. So I wanted to run through the process with you. All right, we now know our function. We already knew a was 2. We just figured out b was 3. So my function f of x is 2 times 3 to the x power. Let's try another one. Once again, I'm given 2 points, one of which is the y-intercept. So I already know a is 2.1. So y equals 2.1 times b to the x. I'll take my second point and plug it in. $9.7 for y and 5 for x. All right, I want to solve for the b, of course. And this time the numbers are not going to come out quite as evenly. So when I start dividing, 9.7 divided by 2.1, I have about 4.619. To solve for b, I need to get rid of that fifth power, and I'll do that with a fractional exponent. I'm going to raise it to the 1/5 power, and I'll have to do the same thing on the other side of the equation. At this stage, I want to show you something that will improve the accuracy of your answer, and it's going to be especially important in my math lab because, as you know, they're pretty picky, and it's easy to get off by just a tiny bit if you don't do this. Rather than type in 4.619, I'm going to keep the entire decimal that was in my calculator. The calculator just highlight it and press enter, and it'll repeat itself. In Desmos, of course, on a computer, you can copy and paste. And I'm going to raise all of that to the 1/5 power. And I get about 1.358. Now that's my final answer for B, so I'll have to round at some point, and my math lab will normally tell you how far. I'm going to go ahead and keep 3 decimal places. We'll see that strategy a few times here in this section. All right, I know A and B, so I'm good to go. F of x is 2.1 times 1.358 to the x power. So both of the examples we've done so far, we've known A right away because we were told the y-intercept. These last 2 examples, that will not be the case. So we've got 2 points, we want an exponential function, and notice neither one of those is the y-intercept. So I'm going to go back to my basic exponential function, y equals ab to the x, and I'm going to plug both points in. I'm going to start with this one. Y is 6. Actually, you know what? I'm going to do the other one first. It doesn't really matter. Excuse me, but I'll show you why. I'm going to plug this one in first. Y is 18 equals a times b to the 7th power for x. And then I'm going to plug in the other one. Y is 6, and that's equal to a times b to the 3rd power. All right, the trick on these is this next step. Divide the top equation by the bottom equation. So divide, divide. That's actually why I switched the points. I just wanted the division to come out to a whole number, but it doesn't really matter. Fractions are fine too. So dividing 18 by 6, I'm going to get 3. And then here's why the strategy works. On the other side, the a values, a divided by a is 1. So that gets rid of the a's, and I only have b left in my equation. Subtracting my exponents, I'll get b to the 4th. And then solving for b, I'll have to take the 1/4 power on both sides. And I get about 1.316. Now again, if I'm rounding my final answer to 3 decimal places, that's how I'll eventually put b in for my final answer. but I'm going to save all that in the calculator because I'm not really completely done yet. I still have to find a. You can use either of these equations to find a. It doesn't matter which one. I tend to like to use the one with a smaller exponent. Again, it kind of minimizes my round-off error. So I'm going to go back to 6 equals ab cubed. And I'm now going to plug in the b value that we just calculated. All right, let's do the 1.316 to the third power. But I'm not really going to just do 1.316. I'm going to use that entire decimal value raised to the third power. And it's about 2.28. And that will be multiplied by a. To calculate a, then, I just have to divide by the 2.28. So I'll take 6 divided by that whole number. And I have about 2.632 for a. All right, I've got enough to write down my function. F of x will be 2.632 times 1.316 to the x power. We have one last example here. This time, instead of giving you 2 points, I've given you a graph, and I'm saying, hey, find the exponential function that's shown in this graph. You can see it looks like an exponential growth function. And I'm actually going to turn this into a problem that's very much like the one we just did. I'm going to pick 2 points on this graph, but I do need to pick points where I can really tell that the x and y values are both whole numbers. It would be great if I could get the y-intercept, but unfortunately I can't tell quite what that is, right? Could be 1.5 or 1.52. I mean, I really don't know. So instead, I'm going to look at this point and say that looks like it goes right through the corner there at 2, 3. I'm kind of following along here. Looks like right here, 5, 8 maybe, is the next point that looks like they're nice whole numbers. So I'm going to use 2, 3, and 5, 8 as my points to calculate my exponential function. All right, y equals ab to the x. We always start with that. And actually, I'm going to go ahead and I'm going to deliberately do this one with a smaller one first because I just want to show you what happens. It's still very doable. I'm going to put in the 2, 3 first. Y is 3. X is 2. And then I'm going to put in the 5, 8. Y is 8. X is 5. And then I need to divide my equations. Three-eighths actually comes out evenly as a decimal, so why not do it? 0.375. Once again, the a values just divide out. And notice this time when I subtract the exponents, I'm going to get a negative 3. That's fine, we can work with that. B to the negative third. To get rid of the negative third power, I'm still going to use the reciprocal exponent. It's just going to have to be negative 1/3. Again, remember your whole goal is just to get b, or b to the first. And when you multiply negative 3 by negative 1/3, you do get 1, so that's fine. We'll do the same thing on the other side. So this time if I want to type 0.375, I can because that decimal was exact. Raise that to the negative 1/3 power. It's about 1.387. All right, I still need to find the a value. So I'm going to go back to this one I have here in pink. Got the smaller exponent, although it really doesn't matter. You can use either equation. And I'm now going to plug in the b value that we just found. All right, so I need 1.387 squared, but I'm actually going to use the complete decimal form, at least as far as the calculator gave me, and square that. About 1.923. And that's a multiplier now of a. So to finish this up, I need to divide by the 1.923. And I get about 1.560 for a. All right, I know a and b, so I know my function. F of x is 1.560 times 1.387 to the x power. All right, that brings us to the end of section 5.2.